I'm going to be starting work on a new project, and the goal of it is to visualize the address space of any arbitrary process on Linux. So, the first part of that task is to visualize the maps for the process under procpid maps. That's fairly straightforward to do. But what I also want to be able to do is show the actual raw bytes and interpret those bytes in a meaningful way. And to do that, I'm going to be using ptrace to intercept and suspend execution of the process. Process VM read v is a syscall to read memory directly from the trace process into the tracer. And then I'm going to be doing some diffing, most likely, to show where memory is being updated. And I want this to be highly visual. So I'm using this library called Raylib. It's just popped up on my radar several times in the past couple months. It's a really straightforward C library for doing, video games, basically. But my use of it is going to be for visualizing the memory of the process. And I think I'm going to be dividing the work into at least two separate threads and hand off UI state and memory state between those two threads. So the tracer process is going to be doing all the work of like gathering the state data, writing it to its own memory, and then signaling to a thread to flush all that out to the screen, basically. So yesterday I did a bit of a little prototype to start getting my ideas together in something concrete. So I just wanted to show that off real quick here. I'll go ahead and full screen this. So I got Zoom working. This is just a buffer. So I guess I should explain what this is actually showing. So this is a buffer of 1K of memory. Obviously not a huge amount of memory here. I tried running this on a megabyte and it just was not performant. So I'm going to start on small amounts of memory and then add optimizations, things like culling objects that aren't on screen, consolidating them so that I'm doing less work on the thread that draws to the screen. Because Raylib, I looked into it last night, Raylib, all the instructions, all the draw instructions that you issued out to the graphics libraries have to be coming from a single thread. They're not multi-threaded. So that means you have one thread of execution that is doing all that work, and currently it's maxed out doing all this work. So I'm gonna have to do a lot of work on optimizing this. But I got a basic zoom going. You can see as you zoom in, you can see the actual values. Everything's zero here except for at the top. You can see like I got a little bit of test data in here. But yeah, this is the basic idea. Each one of these rows is a cache line. So it's 64 bytes of memory that's 64 byte aligned. And inside of here, you can see there are little 4-byte groups and then 8-byte groups. So each 4 bytes would be like a 32-bit integer, say. And each 8 bytes would be like a 64-bit integer. If you had like a complex number, like 128-bit, would fit into these little sections here. So the goal is to have a visualization that you can zoom all the way out and see all of the virtual address space with proper like indication of what is what, and then be able to like zoom into areas of interest, actually see the raw data and see it updating in real time. So having some type of visual indication that these cells are the things that are changing between each polling interval or whatever. But yeah, that's the general idea. I have a lot of ideas for things I want to do, such as like adding disassembler support for text sections, reading the dwarf information of the program to be able to interpret bytes in memory. So if there's known formats in memory, being able to display those, showing like the shared objects. Procedure link table, the global offset table, showing the relationship between those and how they reference external functions and stuff like that, I think would be really interesting to do. And then just being able to zoom in and like select bytes and then reinterpret them as different values, I think would be helpful in my own learning, but also in like an educational context. I feel like, at least in my experience in my undergrad, I wish I had a tool like this that would just show me all of the memory of the process, how it's laid out, how it's interpreted, and how the program is executing. Another feature would be to show the instruction pointer for all the threads inside the process, so you get a feeling for where those threads are executing, showing their stack pointers, stuff like that. Basically taking the execution context and visualizing that as well. So yeah, lots of ideas. But yeah, this is just like the basic rough idea of like showing each byte as a cell and then zooming in and out. Next steps for me will be to implement a zoom that is less manual. So right now each cell is responsible for calculating its position and its scale based on a global zoom value that is modified through wheel scroll. And you can see the ramifications of that is that when I zoom into the top center of the memory buffer. But what I want to be able to do is zoom into where the mouse is pointing. So you can, hover over an element and then zoom into that area to select individual cells and stuff like that. So the next step will be to pull out all that scaling logic into something that is like a canvas type object where I'm placing cells into a canvas. And then I can scale that canvas not only by a zoom factor, but also by a position into that canvas. So I'm thinking it's probably going to be a two-dimensional matrix transformation of some sort without rotation. So it should be fairly straightforward to implement. And there might be pre-existing code for that already in Raylib or another library I might use to reduce the amount of work. But that is the goal for today, is to get this zoom working on where my mouse is pointing at on a global canvas. So I'm not zooming into this fixed point here. And then I think a stretch goal would also be to draw the actual or the text for the addresses on the left-hand side here. So like you would see in a debugger or like a disassembler, basically just drawing the addresses, so each byte on the left-hand side here, drawing their address there. And also I want to draw the cells, so the starting address for the cells, I want to be offset into a global view. So if your address, say your address started halfway through a cache line, it should show halfway through each one of these lines, because each one of these lines represents a cache line. So I think those are the three priorities for me right now: is mouse-based zoom on a global canvas, drawing the addresses for each cache line, and displaying the byte offset into the cache line if the address range starts at a certain byte offset. So yeah, that's what I'll be working on today. And I want to do these check-ins periodically just to show my progress and stay motivated. So I will be updating the channel incrementally on this project as I go.